You see slides?
Yes. Yes.
All right, brilliant. Let's I've got a 30-minute presentation, but there's going to be ample time for questions and answers at the end. So I guess this is the order of I didn't. It says welcome speech and advisement presentation. I wasn't sure if I was supposed to give a welcome speech. I'm not part of the technical program committee, but hey, everybody, welcome. I'm George Corser. I'm a faculty member at Saginaw Valley State University. I teach computer science. And last year in this conference, I published a paper on using ChatGPT to teach a certain subject called theory of computation. It's a 400 level undergraduate computer science course, but the stuff that we do is very relevant to all teachers. Anyway, so to this year I updated it with the material that the new ChatGPT version and some new material. So if you want to look at the old paper, you can certainly do that. The new paper will be released November 1st, but let's get into it. So all I'm going to do is I'm going to show you, but I'll explain what the topic is and what the problem is. And then we'll look at some areas where ChatGPT made improvements. We'll look at some areas where there was no improvement, even though it was a fairly simple problem, although it was a long problem, but a simple one. And then we'll look at some hallucination examples. If you want to get a copy of these slides, the URL is at the bottom of every slide. And if you want to grab them yourself, they're here. Sometimes people have questions after the presentation. You want to make sure you have access to them. So let's take a look at some of these items. So here's the deal. Theory of computation is a complicated subject. So sometimes students might want to use ChatGPT to cheat on their homework because they don't want to have to go through the mental process of learning all the material. It's tempting. Students who want to genuinely learn it might want to use ChatGPT as a learning aid, like a private tutor. And then us teachers might want to be able to use it to help write homework problems, write exam questions, or any number of ways that we might use it to help our teaching. Now, we don't have time to cover all this, but we should be aware that ChatGPT is a significant advancement in the field of artificial intelligence. It's one of the fastest adopted technologies of all time, and it has a massive market share and all these other things that I could present to you, but I don't have time to get into all that stuff, but those are important issues. But we'll have to set those aside for now. So what are we trying to figure out here? We're trying to figure out how can we use ChatGPT to cheat on homework, to learn a subject, complicated subject like theory of computation, and how we might be able to use it as teachers to help us do teaching. So what is ChatGPT? Last year, there were people who did not know what it was. I don't know if anybody in this audience today is in that situation. You probably all know what ChatGPT is, but it's just this computer program that allows you to type in some words and it responds back with the most relevant words that it can think of. It's called a large language model, or LLM. And basically what you do is you just, you give it a prompt, and which is just a sequence of words or strings, and then it'll respond back with another sequence of words or strings. Last year, ChatGPT was 11 months old. Now it is a year, 2 years old almost. And it's already gone through many versions, and there's more versions coming. Last year's paper was all done with ChatGPT 3.5. This year's paper is in ChatGPT 4.0. But there are some newer versions that are out that are beta versions, and I do get the paid version to check it out. So be aware of that. The new results are from a newer version. Okay, so what is theory of computation? In in the computer science field, we teach the computer students how to program, for example, how to program computers, teach them how networks work, and teach a lot of technology-based things. But there are some mathematical fundamentals that are part of the field. As a matter of fact, the computation itself was really a branch of mathematics. Everything that's done on a computer could be done on paper if you had enough time. So anyway, the foundational material is mathematical proofs. It's basically the idea that you can prove what a computer is capable of doing. It's the limits and capabilities of the entire field of computation. That's what the field theory of computation is all about. The problem with it is most students do not have a great deal of experience with mathematical proofs. Most of them, well, I would say a good number, I don't know about most, I haven't measured it, but a lot of them hate math, which is surprising, you think, considering that they're computer science majors, but they hate math. A lot of students hate math. Even if they like math, some of them will hate story problems, which a lot of these problems are narrative story problems. And even if they like story problems, they might hate proofs because there's a difference between, figuring out some riddle, a story problem like that, versus trying to prove rigorously that something is true. And then even if they do like proofs, they might not like the kind of proofs that we do in theory of computation. One of the classic proofs is the halting problem, and another one is Russell's paradox. Here you can see, if you're familiar with predicate logic, the upper right-hand side shows how you write mathematically the problem that's in the other text box. If I tell you I am lying, then if I'm telling the truth, I really am lying. But if I really am lying, I can't be telling the truth. It's kind of a circular type of a problem. They call that an undecidable problem. So sometimes we'll prove things in this way, and a lot of students hate it because it's complicated. And so the bottom line is, do students have, can this ChatGPT be used to solve these kind of tricky proofs? So a simple proof might be, can we prove that the square root of 2 is irrational? When we say that the square root of 2 is irrational, it means that there's no integer a or an integer b where you put a divided by b and it equals the square root of 2. Because you could make a ratio out of it. Well, if you type into ChatGPT, prove that the square root of 2 is irrational, it comes up with a beautiful proof. It's absolutely elegant. So when you read that, it's like, wow, this is pretty impressive work. And so you think, well, maybe maybe it can be used for a lot of other things. Of course, in truth, the LLM is not it's not calculating anything. It's just finishing off the paragraph, if you will, or the narrative with more words. So if you say, prove that the square root of 2 is irrational, it finds the words in its training database and generates those words. So it doesn't really understand things. And of course, that's a very simple proof. Even though it came up with a really good answer, it's a very, very simple proof, but some of the proofs in the course are much more complicated. Now, last year, there was no, I searched for similar works, but there just hadn't been enough time or whatever, publication venues, where there was any literature out there on the capabilities of ChatGPT in theory of computation. I found one paper on Archive, and it claims that the West Point Military Academy, the theory of computation course at that academy, can be passed by the ChatGPT with a B minus or B average letter grade. Now, I read this paper. It didn't look as detailed as I would have preferred, so I'm skeptical about this conclusion. But then again, I haven't contacted the authors yet to find out. The lead author is an undergraduate, according to LinkedIn. So, but the only paper that I could find out there that talked about ChatGPT and theory of computation was optimistic that it was able to do a significant amount of work. Let's take a look at my results and you can be the judge. So in my paper, I'm trying to compare 2023 with 2024. In 2023, I ran a test on a question in this textbook. It's one of the most famous textbooks, if not the most famous textbook in theory of computation. And it's problem 3.5. It's actually exercise 3.5. And it has these 4 sub-questions. And that little A in the upper left-hand side means the textbook has the answer in it. So the textbook answers all 4 of those questions. Yes, the answers are yes, no, according to the textbook. And I suggest to you that we can accept the textbook as quite accurate because it's been checked and double-checked. This is the 3rd edition of the textbook. It's been around for decades. And I tell you right now, as a computer science person, these answers are correct. So let's take a look at what happened in 2023. In 2023, I asked the first question. It got it correct. I asked the second question. It got it incorrect. Third question, incorrect. Fourth question, incorrect. It basically got 25% of the answers correct, which is less than random guessing. I mean, 50-50, you'd think they would get 50% correct, right? They were yes or no questions. I asked the same question of ChatGPT 4.0 just this morning. Actually, these screenshots are the most current. And although it gives the lowercase versions of the Greek letters, it should be capital gamma and capital sigma. The answers are correct. The answers were yes, no, yes, no. The first one guessed yes or answered yes. Second one answered no. And the explanations are correct as well, by the way. The third one answers no, but I will tell you that the correct answer is yes, but it's an exception. So generally speaking, the tape moves left to right, but if you happen to be in the first square, then it stays where it is. So even though it gave an incorrect answer here, I wouldn't say it's a trick question, but it's everything that it says is true except for in that one exception. So basically, it got 75% correct according to the textbook instead of 25%. So that's improvement. Let's take a look. Now that question was involved Turing machines, which is in the chapter 3 of the textbook. Here's one from the chapter 1 of the textbook. So this one said, write in a regular expression that recognizes an even number of A's and an odd number of B's. So it generated this regular expression. Anyway, it says combining these elements, the regular expression matches the strings with an even number of A's and an odd number of B's. So it says matching strings. The very first string is BB, AB, AB, AA. That has an even number of B's, not an odd number of B's. Basically, all of the strings that it's offering as examples are wrong. They're not in the particular language, except for the very last one, which it says it's a non-matching string. So basically, it gave just a wildly wrong answer. I ran the exact same test this morning. I've ran it several times, and it's still wildly wrong. Like, for example, here it gives me an answer, and I say, well, BBAB is in the language, but the register does not recognize it. Then it says, oh, you're right, it should be in the language, and then it gives me another more complicated regular expression. And, basically, I didn't want to keep on going. It gives a lot of hallucinated, completely wrong, fabricated answers that just are not right. The real answer is the answer in the lower right-hand corner. That is a long answer, but it is, you can generate that answer using a computer program. So if you take the input on the left and you go to this particular website, it'll generate the regular expression on the right. So what does this mean? This means that a computer program can generate the regular expression, but a LLM is not going to be able to figure out the intricate relationships that are necessary in order to give an accurate answer, at least not right now. In the current state 4.0, it's not able to do it. So let's take a look at a couple of more. This one's a little more fun. It's hallucination. I think you're going to like this one. So one of the interesting properties of languages is they can be regular or context-free. Regular languages are simpler languages, context-free are more complicated languages, but all regular languages are context-free. That's the relationship. Just the set of regular languages is a complete subset of context-free languages. But it went last year when I asked it, in theory of computation, are all regular languages context-free? It said no. Okay, wait a second, that's not possible. It is. They are all context-free. So I said, give me an example of a language that's regular but not context-free. And it gave me an example of a language that was context-free, but it's not regular. So I said, write me a context-free grammar to generate that language. And then it did write me the context-free grammar. So I said, you told me the language of even-length palindromes is regular but not context-free. Now you produce a context-free grammar that recognizes language, which means the language is context-free. So is the language context-free or not? I apologize. It does this all the time. When it's hallucinating and then you catch it in a hallucination, it apologizes. Or at least it used to. Thank you for pointing out the error. And then I gave it another thing and it apologized again. I said, hey, not all regulars are context-free, but they are. So I told them, I corrected a different problem that I had. It had two wrong statements. Then I gaslighted it. I basically said, look, I was just joking. You were right the first time. Then it apologized again. Of course, the previous answers were correct. This one's wrong. But so in 2023, you can see that it'd be very hard to use this as a student, whether you're trying to cheat or you're trying to learn, either way, because the tool at that time, even for simple questions, was giving these complete wild answers and wouldn't stand by them. This year, I tried the same thing. In theory of computation, are all regular language context-free? Yes, it gave the correct answer. Then I said, give me an example of a language that's regular but not context-free. He said, no, that's impossible, which is correct. Then I said, no, you're wrong. I checked my textbook. It's definitely possible to have a regular language that's not context-free. And it said, I appreciate the clarification, but I want to reemphasize that all regular languages are indeed context-free. So it stood by its word. It correctly. So for that level of a problem, at least, it would be useful for a student to learn, because it's not going to change its mind just because you said something wrong. So one more problem I want to show you is a remaining hallucination. It's just because this problem has been corrected from 2023 to 2024 does not mean that they all are. So here's one more example. I showed it an example of a grammar for a context-free language. Write me a grammar. It did. It came up with a nice little grammar for nested parentheses. Perfect, wonderful, fabulous. Then I said, rewrite the grammar in Chomsky normal form. This is a format for the grammar that's common in our field. And then it gave me an incorrect line. So I said, hey, the third rule is not allowed in Chomsky normal form. Oh, you're absolutely right. It didn't say I'm sorry, though, at least. And then it fixed the third rule, but it didn't change the first rule. The first rule is still wrong. So wrong, you can't have a rule like number one either. You're right again. Sorry about that. Well, it didn't say sorry, which is good. I hate when it says sorry. But then it did eventually give me the correct grammar in Chomsky normal form. So, I mean, it was still hallucinating, but at least, it came up with the right answer at some point. So I guess the question that you might ask is, a student who doesn't know the field might not be able to do what I just did there. But somebody who's trying to put a test together might be able to use the tool to do some of the tedious work, as long as you know the complicated stuff. So let's take a look at where we stand. So based on all this information, and these are just examples. If you want to see the final work, you can see in the paper. But basically, on the original program, the problem that I presented, one of them, the original version 3.5 got 25% correct, and ChatGPT got 75% correct. I think you'll find that a lot of the problems, the answers, the number of answers that ChatGPT gets correct is a lot higher than it was last year. Some of the hallucination, like doesn't go away. So there were some questions where there was no improvement. However, as you saw in the third example, there were some questions where there was improvement. In other words, the hallucination was eliminated. So I showed you one where the hallucination was not eliminated, and then the other one where it was. And then the fourth problem was a brand new problem. I didn't have it in last year's paper, but this year it showed that even though it got the answer kind of wrong, by playing around with it, it ended up getting the answer correct. So this research that I'm publishing, it only applies to the table to the theory of computation. In other areas of study, I use it in my web development class. It does really great web code, but for these mathematical proofs, it's just very limited. Definitely, the tools are advancing quickly, so it may be tomorrow that it could do it. But right now, from what I'm seeing, ChatGPT in its current form cannot be used for students for either cheating or learning effectively. I mean, I wouldn't even worry about them having the app on their phone because there's not too many questions, at least in my tests, that they'd be able to answer. So, but it might be useful for teaching. It might be, compared to last year where it was really kind of useless. This year it might be useful for some of the tedious aspects of teaching theory of computation, because some of the problems can be lengthy, and if you want to give the students a problem to work on, you need to make sure that you've thought through the details. A knowledgeable person must evaluate the question, but you might be able to work with ChatGPT to make it happen. By the way, I should tell you, I drive a Tesla, and the Tesla has full self-driving, which is a form of AI, and I find that I want the car to handle the tough intersections, but in fact, it doesn't handle the tough intersections. I have to take control of the tough intersections, and but it handles the long, the tedious driving. Like if you're in a long trip and you want to get the right exit, it remembers those kind of details, or if you want to shift lanes and stuff like that, it handles like highway driving really well. And I think that ChatGPT as a tool to help with theory of computation right now in October 2024, it's useful for handling some of the tedious elements of producing teaching documents, but other than that, it's really not useful. So hopefully that helps clarify my current research.